Hi Chem Peeps, this is part 3 of the mole defined. We're going to do some examples in this video. So we have a problem where we're to calculate the formula units, which is going to be Adamberg on my mole map. And I'll quickly show you that map here in a minute. And I'm given 109.1 grams of calcium chloride, which is going to be Grahamtown on my map. So let's quickly glance at the map to see how we're going to set this problem up. So here's our mole map. Let's just remember what we were doing. We were given 109.1 grams of calcium. So we are starting in Grahamtown. We are asked to find formula units. So we're going to travel to Adamberg. So we're going to have a two-step problem. We first need to multiply by 1 mole over the molar mass of calcium chloride, which I'm going to have to find that mass on the periodic table. I will then be in moles. I then have to take that answer and multiply by this relationship of Avogadro's number, 6.02 times 10 to the 23rd formula units over 1 mole. So let's go ahead and set that problem up. All right, so the first thing we always do is write down the given value, which is 109.1 unit and label, so grams of calcium chloride. The first down arrow told me to multiply by 1 mole of that calcium chloride over its molar mass. Now calcium weighs 40.1 and chlorine weighs 35.5, but we have 2 of them, so the entire mass is 111.1 grams of calcium chloride. I know the problem is set up correctly because when I look at what's in the numerator to begin with, grams of calcium chloride, it divides out with grams of calcium chloride. So continuing on, we are now in moles and we need to go to Adamberg. So the down arrow for there is 1 mole of the calcium chloride in the denominator and Avogadro's number of pieces in the numerator. And in this case, it is going to be formula units since this is an ionic compound of calcium chloride. I know this is set up properly also because the moles of calcium chloride in the numerator cross out with moles of calcium chloride in the denominator. So multiplying across the top here on my calculator, I'm going to take 109.1 times 1 times Avogadro's number. Take that answer and divide by the denominator of 111.1 grams. My final answer is going to be 5.911 times 10 to the 23rd formula units of calcium chloride. Let's look at another example. In this example, we are given 2.03 times 10 to the 26 molecules. That means we are in Adamberg, which is the bottom left corner of our map. We are going to calculate grams, which is going to be Grahamtown, which is the top of the map. I'm not going to look at the map this time. I'm just going to go ahead and set this up. So we write our given 2.03 times 10 to the 26 molecules of water. Now, the first up arrow tells me to multiply by, I'm sorry, not 6 here. Multiply by 1 mole of water over 6.02 times 10 to the 23rd molecules of water, which is Avogadro's number. The next up arrow tells me to multiply by the molar mass of water, which we calculated in part 1 with 2 hydrogens and 1 oxygen as 18 grams for every 1 mole. I know this is set up correctly because if I look at my units, I started with molecules of water and my denominator has molecules of water. My numerator in the middle has moles of water, and my denominator at the end has moles of water. I'm going to be left with grams, which is what they're asking for. Take the given number, multiply by 1, multiply by 18. Take that answer and divide by Avogadro's number. And our final answer is going to be 6.07 times 10 to the 3rd grams of water. One more example. In this example, we are given 3.75 liters of CO2 at STP. Therefore, I can use that map for the conversion. They want me to find moles. So I'm starting in Volume Town, and I'm going to travel to Moleville. If you're going to look at the map, we always start with the given. So we have 3.75 liters of CO2. And the up arrow between Volume Town and Moleville says to multiply by 1 mole of CO2 per every 22.4 liters of that CO2. Notice that liters of carbon dioxide cross out with liters of carbon dioxide. Take your 3.75, multiply by 1, divide by 22.4, and we get 1.67 moles of CO2. And that is how we convert units of moles. You can find me on TikTok or YouTube at Chem's Chem Chat. I hope this helped, and I will see you next time.